In this series, we are going to look at assembly drawing and why we need it in engineering. So basically, an assembly drawing is a drawing that shows how two or more individual parts are connected together or how they fit together to form a complete machine or a product. Most times when we buy products, they are separated into different parts and we are given instructions on how to assemble those parts. So this is a course in assembly drawing to look at how different parts fit together or the relationship between two or more parts. So why do we even need assembly drawing in the first place? We say 1. It shows us how parts fit together in a machine or a complete product. It also shows us the correct position of each part when we are supposed to assemble them. It can also help us in assembling a product, and when it comes to maintenance and repairs, we know how to disassemble the product. Then we can also check whether there are missing components in a delivery or procurement. Assembly drawing also tells other engineers or other people what the designer actually intends to do. So there are other reasons why we must assemble, and as a student or as an engineer, you should know how parts come together and how they relate with each other. Drawing one part is different from drawing an assembly. So a part drawing only shows one drawing at a time, but an assembly drawing shows many components that come together. We can also say that part drawings are used for manufacturing, but assembled drawings are used to assemble the manufactured product. Then the part drawing contains complete dimensions, but an assembly drawing usually contains only overall dimensions. Sometimes there is no dimension at all. Also, the part drawing shows the material that is used for the parts and the tolerances around the material, but an assembly just shows the relationship between the parts and how they fit together. Then in a part drawing, we have only one drawing per part, but in an assembly, we have many drawings that are coming together to complete the product. Now let's go on to look at some types of assembly drawing. We have the first one called a general assembly, which just shows the entire machine as it is assembled. Then we have the exploded assembly, where parts are removed slightly to show how they fit together or where exactly they are supposed to fit in a complete product. Then we also have the sectional assembly. So some parts within the product cannot be seen from outside the product. So we have the sectional assembly, which shows some parts that are cut away to reveal the internal details of the product. And what do we need to see in an assembly drawing? So the components of an assembly drawing are 1. We need a title block which shows us the date, the scale, the person who is drawing the thing, and any other detail that we can get from that particular paper. Then we also use balloons or leaders to communicate with any reader what certain parts are or what components are on that particular drawing. Then we also need to see the bill of materials. This is just a table that lists every component, how many of them are there, and then the name of the components. Then a very important part of the drawing is the type of lines that you use, because center lines, hidden lines, section lines, and any other type of line tell us different things about your product. So that is the components that we need to see in an assembly drawing. There are other ones that we'll talk about when we start assembling some parts. So here we have some principles of good assembly drawings, which is basically telling us that we should be able to align things well, know where they fit, and know how the parts relate to each other. There are some typical machine elements that we will always find in an assembled drawing, because some of these components just link other components together. So examples are bolts and nuts, we have washers, we have keys, gears, bearings, pulleys, and all that. So all of these elements are used to assemble parts. And in our next session, we'll see how these elements are represented on paper.